Today, we are talking about running electrical. I know, it's something we haven't touched yet, but I'm working on my own house here, so I've pulled my own electrical permit, and I'm going to take all the years of experience and knowledge that I've gained from electricians, I'm going to put it to work in my own bathroom, and I'm going to update my wiring from just a plug and a switch to all the modern amenities. So before we get started, let's talk about the legal implications of wiring in your own home. If you do wiring and it doesn't get inspected and it's not on a permit, in a lot of cases, if you run into any kind of issue, your insurance company is going to run for the hills on you. So, disclaimer, if you own your own home, most jurisdictions let you do your own electrical work in your house. Depending where you live, you might have to call in for a permit. So double check in your jurisdiction before you go ahead and do anything like this, because this stuff is dangerous, and if you don't do it right, you could run into a serious problem. Now in this particular case, I'm working in my own home. I did call the ESA, which in our area is called the Electrical Safety Authority. You put out a few bucks and you get a permit. In a lot of cases, it's based on how many electrical fixtures you're doing. So it's a real simple application process. It's less than $100 in most cases, and it's definitely worth your time and energy to do it if you're comfortable doing this sort of thing. Now, almost everything in your bathroom is going to run on a 14 gauge wire. So that's a 14.2 or a 14.3. Don't know too many situations where you'll need a 14.3. So if you go buy one spool of 14.2, you're going to have enough to get all the way to your electrical panel, wire your whole bathroom, and you'll be good to go. So this is going to be our power feed for our first circuit. In this bathroom, we're going to run 2 circuits. And that's because I want to have a GFI plug. And I'm also putting in a heated floor system. So in my heated floor system, I need to have that on a GFI breaker. And I also need to have my GFI on a GFI breaker. So when I put them together on the same circuit, I have enough power to take care of the hair dryer and the curling iron and that sort of thing, and run the power for the heat. Now the heated floor, because it's a small space, is only going to run about 2 amps. So I'm not going to run into a problem where I don't have enough power, but they both have to be on the same type of breaker. So by doing that, it solves my problem. The second issue that I have is power for all of my lights and everything else. And that's just going to be a regular 14.2. I'll also run the bathroom fan on that. And there's more than enough room on a breaker for running all of my LED pot lights, because they don't take in really any power. My heated towel rack and my fan, I have a little extra to go. So I'm more than safe here, adding 2 circuits. In another video, we'll talk about working at the panel, but what I'm going to do is I'm just going to run my feeds, get my rough in passed, and then I'm going to actually hire an electrician to come in and wire it to the panel. My panel's a little outdated and it's a little outside of my toolbox. Now, knowing how to do your proper electrical rough in will save you a ton of money. And I'm going to just show you, in our area, we have to use staples to hold our wire in place. Okay, and these staples on the package will tell you what wires that they're rated for. So this is good for a 14.2 and a 14.3 wire, which is what we have, which is lovely. And generally speaking, our building code requires us to have a staple every 5 feet. So what I do is I put one at the bottom, one in the middle, one at the top. That's overkill, but what the point of the staple is designed to keep this wire in place during the drywall installation. Which is why if an electrician runs a wire after the fact, he can just drill holes and fish it around. Because what they want to make sure is that this doesn't happen. You never get your wire in front of your stud before the drywall. And if you don't use staples, you'll see how flimsy this stuff can be. We've seen it all the time. We pull a wall off and we've got a compressed wire. Compressed wires are dangerous because they heat up and they can cause a fire. Which is why when you're putting in your staple, you don't bury these little tabs into the wood. And that leaves tons of room for the wire to move around so it's not under any kind of compression, and yet it holds it in place so you don't run a problem with your drywall. Now, in this particular bathroom, I'm going to be putting a strapping on the ceiling. So I'm going to put 1x3s every 16 inches or so. So I have a channel that I can actually run all my electrical right up against my floor joist. So all I have to do is make sure that I'm coming into my ceiling cavity inside the wall area and then wrap underneath and come across. Again, making sure I've got a staple every 5 feet. Yeah, so that gives me the ability to not have to drill so many holes, which is awesome because I am short and I can't reach that with a ladder, and that's a lot of drilling on a ladder. Now, in order to bring this wire down, we do have to go through the plate. So what I'm gonna do is I'm gonna drill with my auger bit here. Okay. Love it. Here's my box, and this is a 2-gang box. It means I can have 2 different functions on it. We're gonna have one for our lights, and we're gonna have one for the fan. The other power for the thermostat is gonna be in a separate box. We'll put that on in just a minute. These boxes come in 2 different kinds. This is called a welded box, which means the sides don't disengage. There's a different kind out there that's called a gangable box, and the sides actually have little screw locks, and you can disengage them, and you can build on and add them longer and longer and screw them back together. Those are really common in a lot of commercial applications, simply because people are always changing their mind about their electrical needs. They have drop ceilings. It's really easy to make adjustments. But in a residential environment, if you buy the welded box, it'll save you some time and energy, because when you put that on your stud and you screw it in, you're good to go. If this is a gangable box with screws, you then have to go and grab some 2x4 and screw that onto the other side of the box according to code. And that has to be attached to the drywall. And that makes sure that this side plate never comes disengaged from that box. It's a lot of extra work, and you're only saving 20 cents. So I say get the welded box, make your life easy. One more quick mention before we get going any further. Because you're in a bathroom, we have to watch the golden rule. That is 36. Your electrical switches have to be 36 inches from any contact with water. All right, that's very brutal. So my switch is going to be here, and I'm going to measure over to where 32 inches on my shower wall is. I got to make sure that I'm more than 36 inches away from the edge of that glass. If it's anything closer, you'll fail your installation. So you might want to think about where your switch location in your bathroom is going to go. In a lot of cases, that's one of the things that causes these inspections to fail. So you might sometimes see it on the outside wall, and then the door swing will change. So there's a lot of little nuances here. Make sure you just think through your plan so that your switch location is going to be more than 36 inches away from contact with water. So just in case you're wondering, my switch is going to be exactly 37 inches from the edge of my glass, which is more than enough. Now before I mount the box onto the frame, remember one thing, we're going to be adding our wall surface and then a casing on our door. Keep in mind your options for your casing, because there are a lot of different options out there. Traditionally, like a new house built with basic builder trim, it's going to have a 2 1/4 or a 2.5 inch door casing. But they can come all the way up to 3.5, 3 3/4, and more. So you got to figure out your design before you rough in your bathroom. And if you're not sure, you got to add a little build out. Okay, and this is a really simple way to do it. Whenever I'm working on framing a house, I always leave my scrap lumber around. So when my electrician shows up, he can do this. And I don't want him to be coming to the job site and not having 2x4s. Because if he doesn't have them, he'll mount the boxes without them. And then it's my problem later. So there we go. Now I've got lots of room for my casing before my box. I'm not going to run into any situation, even with the 3.5 that I'm using. Don't forget, the box isn't the side of the finish. You also get a cover that goes over that. Okay, and you don't want to have to be cutting the cover plates down in order to make them fit or have them just up against the wood. It's always a nice finish to have a little bit of wall showing, so give yourself a little extra room. So when I'm mounting my boxes, here's my rule. I like to have one space for my wire to come in. All right, and these just break off, nice and easy. And then I take my power in, and then my power out, I like to come from the bottom. And the reason I do that is just so that I don't get confused down the road. Makes my life easy. Here we go. Now, I'm going to set this bad boy at a comfortable height, 54 inch. Here to the top of my box. And you'll see that there are tabs on the front of the box, and that is designed to set the depth up against the frame. And the tabs at the back are designed to hammer into the frame. Now, you can just push that into the softwood lumber like that, nice and easy. After you get that done, make sure you get some number 8 screws, like 1.25 inches, 1.5 inches, and mount this thing so it'll never move. Okay, now your box is secure. Woohoo! Okay, now we're gonna just rough to mate. That's about where it enters the box. Then we're gonna cut our wire off because this is our power feed in. All right, now here's the secret. Always give yourself extra. This much wire is pennies. So give it to yourself. Why make your life difficult? All right, now I'm short for this and I'm gonna just find that hole. All right. So in the code, it talks about every 5 feet you need a staple. Anytime you drill a hole through lumber and run the wire through it, that's considered a fastening system or a staple. And so you don't need to have it here to here. You can run the box straight in. But the code also says you need a staple within 12 inches of the box. So what we do is I like to always run myself down here like this. 12 inches from the box is a foot. So I'm gonna be fine right here. Okay. Done. Now, I'm gonna leave a little bit of extra, okay? I always want a little extra loop on my feeds in every direction. And the reason you want that is, say 10 years down the road, somebody makes a change, they open the box, and the tip on the wire is been curled around the screw, and when they're done taking it off, when they go to reattach again, it breaks off. Well, then they got to pull more wire into the box, cut the sheathing back, and then start over again. If you run it all straight like that, you're going to run into problems, possibly for yourself, but you'll drive other people nuts. And so try not to do that. It's not necessary. Here we go. Now I got extra. I'm going to just get rid of that now. Now, when your wire comes into your box, right here, you actually want to see the protective coating on both of these wires inside the box about 1/4 inch, okay? So from that point down, I'm gonna remove the trim. Now I can use my knife and just cut down the middle, peel this open, okay? And that's it. And that's good to go. All right, there we go. Now, you can see the sheathing is on there, okay? Next step would be to close that. See, there's a little bracket here that tightens onto the wire. And nice and easy, right? You don't want to be too tight on that either because you don't want to create compression on that wire there. Then you want to take your ground, put it around your screw, tie that on, and then you take all of your feed wire, okay? And just curl it up. Now remember, nothing in this box is going to be live until you connect it at the panel. So what we do is we actually are going to power up the box and get all the switches on before we connect to the panel. So you never have to worry about morettes and never have to worry about anything being live because none of these are connected to the panel yet. Okay? Now, this is my power in, and my first switch is always my lights. My second switch is always my fan. That's how I like to do it. If you're not sure, and maybe you don't remember, you can always put a little code on the box with a magic marker. Light and fan. Now when you come back later, you'll remember what's what. Nice and simple. So now I've got power to my box, and this one feed is going to take care of the lights and the fan. All right. So now I want to run a wire from here up to my first pot light, and then I can connect all of those wires for all the rest of those pot lights. And I also have to run one from the fan over to where my fan's going to go and just leave a loop in the ceiling. Okay. So remember, like I said, I like to have my wire coming in from the bottom. So I'm going to, again, cut my sheathing. Feed that up into my box. Make sure that my sheathing is showing. Tighten up that screw. Good. Take my ground. And then there we go. Now that's ready. Now in the same regard, this wire has to be attached within 12 inches of leaving the box. Same code applies all the way to the fan, every 5 feet and 12 inches from the box. You need to have a staple. Okay, now you can just kind of guesstimate from here. I'm going 6 feet, 3, 6, a couple for the feed, and a little bit of extra, so make my life easy. And now we're able to run this up. I drill a nice 1-inch hole, so I can run 2 wires through every one of those holes. Don't jam so many wires in a hole that you can't hardly pull them through, or your inspector is going to fail you. Okay, so I've thrown a staple up here, leave a little loop extra in the ceiling, and then I'm bending down, and I'm just going to throw a couple of staples on over to the fan area. So what I'm doing is my fan placement is going to be relatively over the toilet area. I like it there because it's effective, and I don't want it in the shower. I don't want it over my vanity, so it's a nice place in the room. I have one ceiling, so I can be a few feet away from the shower. It's going to have enough CFMs to really pull enough air. Now I'm going to run this staple over to this wall, and I'm going to mount this again because I got my 5-foot rule. All right, now watch. I don't want to have it too tight or too low. That's why I raised it up here. So when I strap my ceiling, every board is just going to be pushing that wire out of the way if I put it up. That's easy. Now I got this coil. Now because I'm going to be installing a fan, that's an after the market fan, so when I'm done I'm actually going to cut the hole, okay? I want to just leave this up in the ceiling. So in order to keep this from having a problem, I'm going to show you my little trick. I'm just going to throw a screw in the wall, in the joist here, to hang that. Now, when the inspector comes and sees this and it's all strapped and this wire is held out of the way, that's not going to be a problem at all, and I don't run the risk of having this wire getting pinched when I'm installing my drywall. And then when I'm done, I can cut my hole, reach up, grab my wire, and look at that. I've got 4 or 5 feet. I can pull the wire through the hole, comfortably wire that fan on my ladder, and then place it all up in the ceiling after. Okay, so now we've got our power to the box, we've got our feed for the fan done. Now it's time to wire the lights. But before we do that, we want to map it out. All right, very important to know exactly where you want your lights. So what I want to just do is visualize my space here. This is my shower wall. This is my recessed nook area. So I'm going to have my shower head coming off of here. I have a 32-inch piece of glass behind me, which means I would like to have 16 would be center, but I can go to 18. I can cheat a little off center. We'll call that center. All right. So what I'm going to have is I'm going to have a shower bar here, and I'm going to have a handle and a shower head, and it's going to be spraying water everywhere. And what I want to do is I want to have a light pretty much right above that. So I'm going to measure off 18 right here, and I'll put my mark. And then I'm going to go 18 inches from the other side of the other wall, just so that the light is balanced, not just in the shower, but also balanced with the bench. So I'm going to have 2 lights in here, which should be more than enough. One thing to remember with pot lights is over the course of 8 feet, it ends up shining about a 5-foot diameter of a circle. So if you only have 1 light in your shower, you're going to have a lot of dark spot. Just to keep a thought, especially if you're going to add a bench, you end up with 5.5 feet. I would put in a second light just so that you don't have that problem. So now we want to run our pot lights, but I need a second hole because I don't want to run more than 2 wires in a hole. I've already made sure nothing's above it, which is important to do. Let the bit do all the work. There we go. Put a bit of a curve into this bad boy, and then it's a lot easier to grab when it gets up there. Yeah, even for us short people. Okay. Now, same sort of thing here. We're just going to come across roughly the same area, right? Our center line on the shower is right here. And so I'm going to come along and I'm going to staple it up here and then leave another curl, another loop here for the connection. You don't necessarily need to staple the wire here. You're less than 5 feet from the fixture. But again, I want to have it up off the side of my joist just for convenience sake. Take your wire trimmers. I like to have 3/4 of an inch to an inch. You pinch, quarter turn, slide off. And what you do is you pinch it on the hole that corresponds to the wire. It's almost kind of way too easy, right? So you hit the 14, because it's 14 wire, and you don't damage the copper. Now that one's done, I'll come back to my plate here. So I need a staple every 5 feet and one within 12 inches of the box. I can accomplish both of those by throwing this staple right here. Okay. Okay, here we go. Up through our hole for the lights now. Now, every light in this room is going to be on the same switch. Okay. Okay. Now remember, if you're renovating yourself, you might not be coming back to do this process for a couple of weeks. So you're going to open up your wall and you're going to be like, wow, what is what? This is where wiring like this works, because you know the wire that comes through the top of the box, that's my power, right? The one on the left, that's my lights. The one on the right is my fan. All my markings are there. This may not be the system you use, but make sure you have a system. Okay, so you have two options when you're running a bunch of pot lights in a bathroom. One is you run a single feed, right? And then you want to make a map of where you want to drill all your holes. And then you can come back later, drill all your holes, fish wire, because we're adding strapping, you have that luxury. Or you can run all your wire in advance. I kind of like to run on my wire in advance. It's just a good habit to have, and then I find it easier to measure off and make my map. So there we go, I'm going to run a wire along, have it sticking down roughly where my black marks are, and I'm going to cut it and then install it. This is so much easier to do before you put it up. And the reason why is because after the fact, you're going to be doing all this wiring, probably working above your head, and that is a long time to be wiring all these pot lights above your head. So if you do it this way, try not to fall off your ladder. If you do it this way, it'll just make it easier for you down the road. Okay, now what we do is with these, we're actually going to just tie them together, a couple of twists, all right, and put them up in the ceiling here so that they don't fall out. Now trust me, when you've drilled your hole, it's real easy to pull this out and then identify these wires and then pull them all down. But this way, you know that nothing here is going to get caught in your straps or your drywall. All right, so my bathroom is actually 5.5 by almost 12. It's extremely long. So when I'm putting my lights, I've really got to take into effect this cone lighting that we're talking about. It comes from the light and it comes down to 5 feet diameter at the bottom. Now when you're walking in a room like that with pot lights traditionally, and that's all this brightening up the room, you don't want to walk from a light zone to a dark zone back to a light zone again, because it's very spooky weird. You know, your eyes are constantly adjusting as you walk through the room because you're entering into different stages of lighting. So what you want to do is you want to try to get enough lighting in this room that it's somewhat consistent at eye level. So you're a little bit more than halfway up, which means I'm going to be about a 2-foot wide beam of light coming off that light at my eyes. So every couple of feet, I really want to have another beam of light picking up the last one, okay? So if that's the case, I want my lights no more than 4 feet apart so that when it gets down to eye level, my beams are intersecting. All right, so then I have a nice continuous light where I'm walking. My eyes aren't freaking out going in and out of the dark and light area. Then you'll see this a lot in basements. They don't put enough lights in. They've only got 7-foot ceiling. It is really weird to walk around because it's like little pieces of light coming through the ceiling. It's kind of strange. That automatically gets me down to almost an 8-foot room. It's a no-brainer on the math. 4 feet here runs me right about here. Center over the door, a couple inches off. I'm going to live with that because I want that to be aesthetically pleasing when I walk in. It's also the area where the toilet's going to be, so it's nice to have some light here. And then we'll go another 4 feet over. Bam. Perfect. That is actually 1 foot from the wall, which is a perfect location for the lights over the vanity. So there's a little bit of light right in front of your face. And then we're going to add a vanity strip light as well. Because ladies, we all know that pot lights are no good for makeup. You've got to have a light on the wall shining directly into your face, or you're going to have a really bad time trying to get your makeup done. If all the light's coming down your face like this, you have nothing but shadows. And that is horrific. So here we go. We want to cut the wire before we go up on the ladder. So we know we're 4 feet apart, right? Grab your wire, stretch out your hands. 4 feet. A little bit for that tail, a little bit for the other end, and then we'll cut it. Nice and simple. Of course, while we're here, we can work below our heart, which is nice and easy on the body. Cut that wire, expose the ends. I'm not worried about it. The reality is when I'm doing my strapping, it's not so much science. 16 inches apart is good standard, but if that's right where my wire is going to go, I'll just make it 14 because I can see everything I'm doing as I'm installing the ceiling. So now it's just a whole lot of rinse and repeat, right? Like, just make sure you leave yourself lots of extra wire in the ceiling so you have a little bit of give and take in case you end up wanting to change some of your wiring design after the fact, which wouldn't be all that uncommon. Here's my second power feed, and this one is designed for my GFI and my floor heat system. So what we're going to do is a lot of the same stuff. I mean, it's still 14-2 wire. Roughing it is almost exactly the same. The only thing you have to do is you have to consider the counter depth for your plug, right? And this is more design than anything because, check this out. I'm going to have a counter here. I like to finish my vanities at 36, but in this particular design, we're putting in a different size vanity. I'm going to surprise you with what it is, with a vessel sink. Now, vessel sinks usually have about a 6-inch rise on them, so I want to actually have my counter down at 30, which is going to be a little bit freaky visually to look at, but that's my counter. Okay, and let's add a little bit for flooring. When I'm sitting here with that as a counter space, one thing you don't want to do is you don't want to have your plug way too up here, all right? Because then all you got to do is you have wires hanging the entire time. It looks like junk. So try to keep everything on your bathroom wall. If this is my counter here, and here's my vessel sink, and here's my tap, okay? Your line of sight now with a mirror, you don't want anything above that mirror line, anywhere around, okay? That keeps it nice and clean and tidy. So that's about as high as I want to go for my plug. I can go from here down to here. I'm going to split the difference on this one and put it in the middle. That gives me flexibility in case another design change yet again. Try to consider that as an option. And here we go. Basic. And, you know, the plier hammer, right? It's just awesome. Okay, now that's my feed. Of course, I'm going to have to put in a staple right here. Put some screws on. Make sure these things aren't going to move around on you. Okay. Next, we're going to drill a connection through our stud wall because I'm going to take power from the GFI to run my floor heating system. And I'm going to locate that box over here just because I don't want to have too much going on in that wall in the one spot. And I'm going to drill this hole. Whew. I don't know what I'm running into there. That's crazy. Yeah, time to get the file and sharpen that bit, no doubt. So I just grabbed my extra long box here, and I realize it's not welded, it's gangable box. And that's the other variety I was talking about in the beginning of the video. So here I'll demonstrate. You can actually loosen off the screw. Oh, there we go. And you can take that off. You can actually screw on the next box and the next box. And then when you're done, you put all these connections back together. And you can put the screw back on. And that makes your box. And because this can come apart, like I said, they require us to add another piece of blocking. So we will do that. Now I'm going to put the thermostat at a nice comfortable height. This is programmable, and you're going to want to be able to see the buttons and read your instructions without bending over and being real awkward. So we'll do that. Have got room on the inside to mount the screw. Done and done. Screw on. Now, pull the tab for your power in. Pull the tab down here as well for the heating cable, and pull the other one for the thermostat wire. Okay? You're gonna have 2 leads coming out of the box and 1 coming in. Do now is cut enough to go from that box through our nifty hole down to this box, and enough to connect it. And I know I've got a lot more wire there than I need. Like I said, it's so much easier to work with the box like that. Now, since there's only power for one other thing coming out of this box, it doesn't really matter. GFIs, the way that they run, is you'll actually wire both of these, all right, into the back of the box. And it doesn't matter which wire goes in which location. Before we get too ahead of ourselves, we'll connect all of our ground wires. Very important, whenever you're putting a wire around a screw, you wrap it in the direction that the screw is going to turn when it's closing, and that'll pull the wire tight into it. Now, the last part of the thermostat wire rough-in is the lead wire. This is very important. This is going to be set up so that you can tape your electrical wire from your floor to the end of this wire, and then you can pull it up through the wall to the thermostat later. Now, basically, what we're going to do here is we're not going to use the whole wire. It's just a little bit too much. It's too thick, it's not very flexible, rather inconvenient. So we're going to splice that off. All right, and we're going to use just the copper wire. Okay, there we go. And what I do is I'm going to attach that copper wire to the ground screw. So there we go. Now that wire isn't going to get pulled out of the wall. I'm good to go. Now all I have left to do down here is set up for the base. So when you're running a heating floor, you're going to have a wire coming down, and it's going to come out at the base plate right at the level of the heating floor. In this particular situation, our floor mat that we're running our cable through is actually going to be attached to the floor, and it's only 1/4 inch thick. So what I need to do is I need to flat bottom hole my plate so I have room for the wires to come in and out of the plate conveniently without too sharp of an angle. Well, she's a beast, right? So again, take care of that one. It doesn't throw you across the room. Keep your blade sharp, you'll be fine. And then what we do down here is we set the wire like that, and then we'll grab one of our electrical staples to hold it in place during construction. All right, nice and gentle. And just keep that right there like that. So now, when we're doing our drywall work, this is out of the way. We've got something we can actually attach and pull our wires through later. That's all done. My power feed is here. All I have left to do now is just add a couple more staples, and that's all done. Now, this wire here is used as a fishing wire, okay? The idea is when you run your cable on your floor for heated flooring system, you start at the end and work your way back to the beginning. and then you connect your ends, and then you pull it all up to the box. Now you generally don't put your heating flooring on until it's all said and done. So this is why you want to have this wire in place. It is really difficult to feed a wire down to the floor, especially if you haven't drilled out the plate after the fact without making a huge mess and wasting a lot of time. So this makes your life really simple. All right, update. So we've got two different power feeds now. We've got our GFI, which will have a GFI breaker at the panel. We have another regular 15 amp that's going to take care of all of our lights and our fan. And there's one other aspect that I'm going to have it take care of, which is really kind of cool. I'm putting a heated towel warmer right here on the wall. It's not a massive unit, and my unit only runs on 1/2 amp. So put that in perspective, that would be the same as about 1/4 of one incandescent 60-watt light bulb, which is awesome. So it's hardly using any power. It's low voltage. It does not have an on-off switch. It just stays warm all the time. So that's a great benefit. You don't have an extra switch. You don't have to come in and push the button and hope it warms your towel up while you're having a shower. It just stays warm. It's not going to heat up the room or anything like that, so it doesn't really affect the atmosphere. But it will make your towels very comfy, so you can leave them on there all the time, and I'm loving it. A couple of requirements for heated towel rack. One of them is electrical. The other one is mounting. And here's the trick. These heated towel racks, because it's an electrical fixture, you got to have a box that the wire can be wired into, and it all slides in with a decorative cover, and then the heated towel rack mounts over top of it. But the other mounts have to be onto a stud on the left-hand side. So if this is my power, my stud has to be where the mounts are. So you have to take your product, have it on site, okay? This is another important, when renovating a bathroom, have your finished products on site when you're doing your rough-in. You'll save yourself a ton of aggravation. So this particular box, the mounting points are 23 inches from the left and the right side. Okay, so if I want to put the mounting in the middle of my stud, that means my other mounting position is over here. Okay, that's my center line for mounting. Make sense? If I come back here, I'm right off the edge of my tub. It's going to look stupid. So I have an option. I can add another stud, but I also have to be 36 inches from this connection to my shower. So I have to be careful because my shower, and it's because I'm building a bench, this is all open, there's no door. The inspector's going to say from this point over, I have to be 36. So here we come to design. I can't be any closer than this point right here. So if that's the case, then I'm going to just mount it on this stud, center line to center line. Now I know I'm good to go. I'm not going to upset the code, and I'm going to have it in a very convenient spot as I walk out of my shower. It's right there in front of me. After that, I've got lots of room to install the toilet and still a ton of space left for the vanity. Really happy with the way this is going to lay out. So let's talk about what we got to do to mount it, because can't throw the box in the middle of a piece of plastic, can I? So we're going to have to do some work here. We want to figure out how high we want our towel warmer, and it's a 24-inch unit. Okay, so maybe something like this. So when you're pulling your towel off, it's nice big chrome bars, nice and convenient. You want to bend down for it, you don't want it above your head. So I'm liking this. We'll go with the insulation line. That's an easy way to remember. So here we are. And the reason I like that is because I have to cut my plastic and open this up now to mount my box. So let's do this right down the middle. And come across here and just fold it out of the way. Now I have to get a piece of 2x4, and I want to, there's the old insulation in the back. I want to get a piece of 2x4 in the back so I can mount my box. Yep, mounted right across the back, and then I'll be able to, that'll be perfect. Now in this scenario, you want to cut your insulation out of the way. Don't just push it. Whenever you fold or push insulation out of the way, you always create an airspace around your fixture. Okay? And that's where you're going to get a draft. So whenever you're putting a metal box on an exterior wall, and even though this is like a second wall built inside the house, it's still my point of vapor barrier, right? You want to wrap it in plastic like this before you mount it. Okay, hey, okay. Let's get a couple of screws in this bad boy. Now that box isn't gonna go anywhere. We're gonna want to run our wire to that. Good. So now I'm going to pull my insulation forward again. Okay. Ta-da. Put this back up. I'm going to force my insulation by stretching it around that box. My plastic here, sorry, I'm stretching it around the box. Then I'm going to pull out what was there. And then I can tape all that together and make sure that I got a continuous vapor barrier. All right. That's actually a video right there, isn't it? So here's the joke, right? Sometimes when you're doing wiring, it involves a lot more than just wiring. There are so many interconnected parts of the building code. First, we want to seal up where we penetrated the vapor barrier in the first place. Okay. All right. And always keep your finger on the back side so you have the starting strip for the next time. All right. Now, there's no such thing as using too much tape. There is such a thing as not having a vapor seal. And the idea behind this is to make sure that air isn't passing from one wall cavity into the room. So, if you're lazy here, you're going to end up with air blowing around. And that is how that is done. And then you're going to realize, I forgot to run the wire. Lovely. Yeah, so I just cut the plastic here. I'm going to run this so I can put my wire in behind the stud here on my top plate, and then into the ceiling cavity. And then I'm going to be running it out of the way after that. Okay. As long as I'm running my wire inside the vapor barrier, it's perfectly acceptable. But remember, you still have to get all your staples in. So you might have to do some creative stretching and maybe cut the plastic and tape it all up and then put a staple in. Do what you gotta do. Okay, so after you're done running your wire in this kind of an environment, and this only happens if you've got insulation and vapor barrier on, and then you change your design. Love design changes. Like I said, if you get it done ahead of time, make sure you're all sealed up everywhere where that wire comes in and out of the vapor barrier. And then we just got to run that back to the box. The trick here is I am doing one thing a little bit differently here. I'm not going to cut the sheathing on this one this time. Instead, I'm going to label it because it's constant power. And when you're wiring your box, you want this connected to the feed black and white. Okay, so we're going to put on here towel. And always easier to write in block letters. Can't use cursive on this wire. All right, and then we're just going to run that over, stick it in the box, and so then when it's time to do the finishing, I know that that goes to the tile warmer, and on low that it gets direct power over there. Beautiful. I'm just going to run that in the ceiling, a couple of staples, and we're all done. So here we go. That's pretty much it for roughing in an electrical for your bathroom. I mean, honestly, if you have anything that you need to run that we didn't show you today, that's going to be quite a spectacular bathroom. Let's face it, we've got lights, we've got switches, we got GFI, we got heated flooring, we got a towel rack. One other quick mention for your vanity light. We didn't show it on the video here, but we're not sure what kind of light we're going with quite yet. So I'm not going to close up until I got that sorted out. There are two kinds of vanity lights on the market. One of them where you have a encased steel box, and you can run all your wire direct into that box and then mount it to the wall. And the other kind requires an octagon box on the actual stud wall as part of the framing. So depending on which kind of light fixture you end up with, you actually run the wire differently. So we don't want to get overly committed until we get that sorted out. This is the problem, you know, one step at a time. Every time you got to make a decision, it has a consequence. So just remember, we're going to tie it in with the rest of the pot lights on the same switch. Make sure you got your staples and all that kind of stuff, and you'll be fine. Now, if you like this kind of content, then please feel free to hit the like button, share it with your friends, and if you haven't subscribed to our channel yet, by all means hit the subscribe button on the bottom of the screen right there. So make sure to check out all the videos on our modern rustic farmhouse remodel, and don't forget to subscribe.